All right, so we are looking at vector components. Thank you. The point of this section is simply this. Are you comfortable that this vector is going both horizontally and vertically? Because it's at a diagonal, right? So what we can do, if I want to actually know how far horizontally and how far vertically this is moving, I can calculate that. Does that make sense? What I do is I take this vector and I break it into what we call the components. So this would be the x component, and this would be the y component. And I do that so that there is a right angle being created between those two things. Does that make sense? This angle over here, where I started from, that would be my theta, which is the angle that this vector is moving at. And based upon that, I can use my trigonometry skills to figure out the length of these sides. If I know this resultant, right, that what I started with, if I know how long that is and I know the angle, I can find the component pieces. Does this look vaguely familiar to you from back in the day? Should be. Pretty straightforward. So let's remind ourselves, how do I do, and if you want to look in your textbook, it's there on page 126, these sine, cosine, and tangent. So if I have the sine of an angle, what are the two sides that I look at? Opposite over hypotenuse. If I'm looking for the cosine of theta. You guys are so excited about this. Cosine is adjacent over hypotenuse. And then last but not least, if I'm looking for the tangent, which is not listed there in your textbook. Which one is it? Adjacent over opposite? Or? Okay, just making sure. Opposite over adjacent. So the whole SOHCAHTOA thing, I learned it as some old hippie came hopping through our alley. Now, you all don't really know what hippies even are at this stage in the game. Not that I really did when I was in school either. But that was the mnemonic we used. Do y'all have something else? Just SOHCAHTOA, right? SOHCAHTOA. Pausing. Back to our program here. So, if I go back to this guy, with this angle, and please hear me guys, and I know you know this, but I'm just reminding you, this angle is what determines what is opposite, what is adjacent, what is hypotenuse, right? The hypotenuse is always, excuse me, hold on. This R, this hypotenuse, is always opposite of the 90 degrees, right? So this guy is my hypotenuse. What is the x in this triangle? It's adjacent. Because it is next to the angle, right? It's part of that angle. And what is the y? It's the opposite. Okay? So based on that, when we make these pieces, we can determine what the lengths of these two sides are. So let's try it once. Is that all right? So let's say that we said that this R was 55 kilometers. And this angle was 35 degrees. Okay. can we figure out these x and these y components? We should be able to do that, right? So, I'm going to add another screen here. If I want to find x, let's start with x. Which of these pieces am I going to use? Because x is which one? X is adjacent. So therefore, we're going to use our cosine. Because we want to know what this adjacent is. We know the hypotenuse, and we know the angle. Okay? So, cosine of theta is equal to what? Adjacent over hypotenuse. But I want to solve for the adjacent, right? So I'm going to call that x. Are you okay with that? So we're saying the cosine of 35 degrees is equal to x over 55. We cool? How do I get x by itself? I get rid of the 55, right? So therefore, we say that x equals 55 times the cosine of 35 degrees. Does that make sense? I'm not sure that you all have done that change, or maybe you have in the past. But rarely are we not given the angle. We'll usually know the angle and we'll know the hypotenuse. And you have to switch the equation around to get it to solve for adjacent. You would. You would. So this is what you'd actually plug in, right? Somebody give me a number. I'm making this up as I'm going along. So can you pop this in for me? Again, make sure you're on degrees. Cosine of 35 in degrees multiplied by 55. You're popping this in, right? And I'm always encouraging you, stay active as we're doing these. So 35 cosine. I am. Why is that? Oh. 35 of cosine. I imagine you didn't have the right, it was on radians and not degrees. What'd you get?
I said 45.
45.05? Yeah, that's what I got. Yeah. So I simply do the multiplication. I get 45.053. What will be my significant digits here, guys? How many significant figures am I dealing with? Just 2. Yep. So therefore, we'll round this guy to 45. And what's my units? Kilometers. I multiplied by 55. Because this was our equation, right? I plugged in the angle. Our adjacent we didn't know. The hypotenuse was 55. Are you comfortable for us to do the y is going to be exactly the same except for what? What's the only thing that would change to find y? Because y is the opposite, right? So therefore I can't use cosine. I'd have to use sine. And go through the exact same process here, except it would be sine of 35 is x over 55. You could certainly, since now we know 2 of the sides, you could do that. Absolutely. Absolutely. So just so we can say we did it, if I want to do 35, take the sine of it, and multiply it by 55, I got 31.54. So y equals 32 kilometers. Now let's take a look. Let's just make sure that makes sense. Okay? So we said that this is 45 and this is 32. My question to you, if I'm going at a 35-degree angle, am I going more up or am I going more out? I'm going more out, correct? So that would make sense that this 45 should be longer than the 32. The x should be longer than the y. Does that make sense? All right. All right. If I'm not mistaken, we've got 6 minutes. Here's what I'd love for you to do. Let me give you 2 problems here. So if I have 23 kilometers and I'm going at a 57-degree angle, that's number 1. And again, I want you to find the components. And number 2, if I'm going at 73 kilometers, and I want you, please, to take this at a 15-degree angle. Find the components. I had more I wanted to do with you today, but we just ran out of time. So we'll let you practice these 2. Again, finding the components. We've got 5 minutes. I'd love for you to spend this time now. We'll check your answers, and we'll go on to vector addition tomorrow.